So thanks so much all for joining us. As Kevin mentioned, that's going to be about developing and debugging WebAssembly filter. So let's start with a little bit of an introduction again. So I'm Edith Levine. I'm the founder and CEO of Solo.io.
Hi, I'm Yuval, the Chief Architect at Solo.io.
Okay, so let's start. So hopefully you guys saw that introduction slide, and then let's move on. So okay, let's start basically by talking about SDO adoption, because I think this is important and you will understand why. In the nutshell, what we see with our customers is that they're basically taking the approach of what called crawl, walk, run, fly. They, most of the time, starting with crawling, which means that they're basically taking an upstream SDO. They need maybe some help. Maybe they need a special flavor like FIPS on ARM. They need a lot of tech advisory. But just when they move into the walk part, what we notice is that they're asking for a lot of customization. They really like SDO. They're excited about the goodies. And then basically what they want to do is to extend it a little bit. And that's what we see with our customers. So that will be the focus of this talk, right? How can you extend basically SDO? So first, kind of like just to level set to make sure that everybody knows how it works. I'm assuming that that's the case, but it's seriously a few seconds. Is that the architecture of SDO is relatively very simple. There is your application as a user that you're basically deploying. There is a sidecar that you basically deploying next to any of your microservices. And then there is what called the SDOD. And the Envoy part of it, the sidecar, is basically what called a data plane. That's basically the part where, the data flow, right? And the SDOD, it's basically the control plane. So the proxies are very, very powerful, but not really, they're not going to decide what to do. They need to be told what to do. And that's exactly where the control plane is coming to the picture, right? It's going to go and figure out, it will listen to your environment, it will get configuration from user, it will look in your secret, and so on. And in the nutshell, every time that something will change, it will update the Envoy proxy. That way that when the request will come, Envoy will know what to do with this. So a lot of the feature that we are seeing in our market is that people are asking for a lot of specific, extension. One of the things that we're hearing a lot is, for instance, WAF, Web Application Firewall, data loss prevention. We're seeing transformation, REST to SOAP, and so on. So this is what we're doing in Solo, and a lot of the time that we did, we basically build it. So let's kind of like explain what does it mean? How can you build one? So extending Envoy, field Envoy, again, we are focusing on the data plane in that talk. So in the nutshell, Envoy is extremely powerful proxy. And what's really lovely on his architecture is the fact that when the request part is coming, it's basically going to what called a filter chain, right? And you can customize those filter chain, including you can write your own code, right? So we, as I said, in Solo wrote a lot of filters that basically can come and you can put them in the filter chain. What does it mean that we needed to do when our customer asked for it? We needed to do two important things. Number one is to actually build it. And because Envoy is a C++, and the filter need to be written in C++ async, it means that a lot of the stuff that we wanted to leverage, we needed to actually build ourselves. There's not a lot of libraries to leverage, which means that it's not a simple thing. It's not as easy to write. The second thing is that once we actually build it, we develop it, we needed to rebuild Envoy in order to include that inside. And the way to do this is with Bazel, and Bazel is a very powerful tool, but extremely complex. So if you don't have to, you probably will not want to touch that, and you will not want to actually build Envoy yourself. So that's that. So Yuval will tell you a little bit about WebAssembly and how it can help us.
Yes, so WebAssembly is a binary format originally meant for the web to run in browsers, right? The motivation was to bring code that's not JavaScript into the web. And recently, there's a movement of running WebAssembly outside the web in cloud-native applications. And it's very appealing because it was designed for the web. It was designed with simplicity and security in mind and performance in mind. All of these properties are also desirable when running in cloud native application and outside the web. So when we talk about a WebAssembly, it's essentially a runtime that we can compile various languages into that format, into that WebAssembly bytecode, and then run it in various contexts, whether traditionally inside your web browser, but now we're starting to see it in other places as well. And one of those places is inside the data path in Envoy. Edith, you want to continue?
Yeah. So just kind of like highlight, basically we borrowed this concept from the web, but the beautiful of it is that we needed this functionality exactly like the web was needed, because we needed something that can run in Envoy. We needed something that is fast. We wanted to make sure that it's secure, and because the way WebAssembly is working, it's basically wrapped in a VM. A VM is very useful. It's very isolated, and the last one is the fact that you can write it in any language. So basically, this is why the community of Envoy decided to bring WASM functionality to Envoy. And basically, the idea is that this custom filter that we saw before now will be able to be part of that filter chain. And the advantage, again, why WebAssembly? Mainly because now you don't have to write C++ async. You can write something simple in different language, like, and we will talk about it more, like Rust or like assembly script. It's very secure because of this VM functionality, so it can dynamically update Envoy. You don't need to, it's really consume. So that's really useful. The third one is the speed, of course, right? I mean, in the nutshell, this is a request path. There's nothing more important than latency, right? You really do not want to put, slow down dramatically the request path. And the last one is the fact that we don't need to build Envoy, which is great, right? We can just take upstream Envoy and basically put whatever we want on top of it. Very useful. So this is basically, now we're going to move 1 second to the user experience, because this is very powerful, but it's also still, the fact that we brought the ability to run WASM in Envoy doesn't make it easy to consume. And that's exactly what we understood in Solo, and this is why we took basically we saw this tweet, which was basically when Lynn Clark, who is one of the founder of WebAssembly, basically announced WASI, the ability to take it and run it in different places. Solomon Hike, the founder of Docker, basically said that if WASI and WASM exist in 2008, it will never create a Docker. So that was really interesting observation to me. And I kind of like saw a parallel between what Docker did with a Linux container to what we did so far with the WebAssembly, which is basically bringing to Envoy, but still the user experience is extremely complex, right? So we wanted to make it simple. And that's basically what we wanted to show you today. So Yuval, now we will walk you through all the demo of the life cycle of WASM in Envoy and in Istio, and yeah, we'll take it from there.
Perfect. So like Edith said, let's go through the life cycle of building, deploying, and debugging WebAssembly filters in Istio. So the first thing we have to understand is that the way WebAssembly filters work, they have a certain contract between Envoy and the WebAssembly filter. And that contract is called the ABI, the Application Binary Interface. And that is a set of functions. And for example, we have one function illustrated here, proxy on HTTP request headers, for example, that the filter needs to implement, and Envoy will call it on the request path as data comes in to Envoy, right? So this ABI, and the reason it's a binary interface, because it's programming language agnostic. This is very similar to an API or an interface, just on a binary level. And that's important because this allows us to implement in any language that supports WebAssembly, right? So currently you have TinyGo, you have C++, you have assembly script, and you have Rust that can all be used to build WebAssembly Envoy filters. Each one of these languages has an implementation of the ABI that makes it more convenient for the programmer to use, right? It makes it feel more native because this ABI is very low level. You see, it has a function name that looks like a C function, has arguments that are integers. So each language, there's an SDK that converts this ABI into a more programmer-friendly SDK that is easier to use. And today we will write some Rust filters, and you will see that the Rust, how the interacting with the Rust SDK looks like. Right, so the first command we're going to see, we're going to use our meshctl, brand new command line tool, meshctl wasm subcommand to initialize a filter for Rust. And that will, we curate examples so you can get started with something that's working, because each language has its own SDK and dependencies and build system. We try to make it easy by getting a few example projects already packaged in there. So this will initialize a base project, and then we will use the wasm build command to build it. And again, in Rust case, it's built using Bazel. So instead of you needing to think about how Bazel works, we'll do that for you. And this will get packaged to an image, and you can see here underlined in this slide, WebAssembly IO, uvalid header Rust, and this is very similar to the Docker image format. And we will later see how we can use this image to actually deploy this filter. So let's start. So I hope everybody's seen my IDE, and let's do the init command. You see it initializes, and let's move on to the next command. You can see here the filter, and I'll run the build, and while it's building, I will talk a little bit about the filter and what it does. So let's run wasm build, and in the meantime, you can see it's pretty much an example filter, and what it does is on HTTP response header, and you can see that now we implement this Rust trait, right? So this SDK gives us a Rust trait out of the raw ABI functions. So the ABI functions, they look a lot like C-style functions. And for us to be able to work in Rust terminology, the SDK creates traits that we can implement. So in this case, we implement the on response header, which means that whenever a response comes in, this gets called. And what we do in this case, we add a response header. So we add a header named hello, and the value will be world and this number. I added a little bit more code here, so it'll be more interesting later, but we'll save that for later. All right, so when we build the image, we have the image ready. The next step would be to push it to WebAssembly Hub. And WebAssembly Hub is a service that we offer that hosts images. Let me just give you a brief view on how it looks like. So this is WebAssembly Hub. And you can see here, if I go into log in and go into my page, you can see all the filters that I've created. And you can see also, if you go to the Explorer tab, you see other filters that other people created. You can see the README tags. We try to really make it the developer experience very easy for you. So now that we have the image pushed to WebAssembly Hub, and do you want to add some things on WebAssembly Hub?
No, just to make sure that everybody knows, it's a free registry. Everybody can use it. There's no money involved whatsoever. It's for the community, and just use it. Yes. It's helpful.
This is solo gifts for the community. So now that it's pushed, we'll move on to the next step, which is to deploy it. Now, the setup that I have right now is a multi-cluster setup for Istio. And what's important here to say is that we need a way to get this filter from the hub to the cluster, right? And the way we do this is we have our own controller that we implemented that allows Envoy to essentially talk to it and kind of stream the filter. And I'll just show this right now really quick, and I'll go and explain it in a bit more details with the slides. So
you want to just do a favor and there's a request to make the browser a little bit bigger.
Oh, bigger? Yeah, of course. Thank you. Perfect. So now the filter is being deployed. In the meantime, let me review what we just covered. So if we go into the side, you can see we talked about WebAssembly Hub. We did the push. Now, the way WebAssembly Hub works is very similar to Docker, so similar that we actually also use the OCI format, right? We created a spec so that the community can collaborate on this image format, and we use the OCI format to store these WebAssembly images. Now, the way the image makes it from WebAssembly Hub into Envoy, we actually, as part of our mesh management solution, Glue Mesh, we've implemented what's called in Envoy an extension config discovery service, right? And what that does is when we do this deploy command, we tell Glue Mesh to deploy this Rust image to the ratings app. It only knows how to fetch using HTTP. So what we do, we using this ECDS feature in Envoy, we can tell the WASM filter to grab the filter itself from our cluster agent. And our cluster grabs the image from WebAssembly Hub and serves it to Envoy in a protocol that Envoy understands.
And I will add that it's also doing it multi-cluster.
Yes. Now that's everything deployed and we kind of have a grasp of what's been happening, let's continue. So next thing, what we're going to do is just to issue a request so we can see that our header was added. And you can see that really we have our hello world header inside the response. All right, so for the next step, it's all nice and well. It'd be really cool if we can actually debug this. And when I say debug, and let me switch back to the slides real quick, what we want to do in the future, it's not something that we have ready yet, but we prepare the demo so you understand the experience we're going towards. We want to make it really simple, kind of like the commands you've seen so far, meshctl, wasm, debug with some workload selector. Yeah. But for now, let me just demonstrate how.
Before you demonstrate it, let me just highlight the so squash there. So, you know, Solo did in the beginning when we actually started the company, we and Yuval built this product called Squash. The idea is basically a debug for microservices. So it's creating a lot of the piping for you. It will understand where to attach. It will bring it all the way to the IDE. Right now, what Yuval is showing you, as I said, this is a demo, but we are very close there. So, you know, very soon you will see how you will be able to run this very simple command like meshctl, wasm, debug, and basically attach that so you can test it immediately.
In our example, we just have a demo command, and this command just loads a Envoy in LLDB. So it takes a second to load. The reason, part of the reason it's still local is that we need to tweak a little bit how Envoy is invoked. We need to run it with a VM that supports debug symbols. So now that we have the debugger, we can tell it to put a breakpoint in this function in the onResponse header. Okay, perfect. Now we run it. And now we need to issue a request because remember this function only gets called on the data path, right? So let me open another terminal here on the side and curl, create a curl. Oops, sorry, curl. Here we go. So the first, there's few functions in the name, so let's skip the first one. You can see that we are now debugging WebAssembly code running inside Envoy, and we can step through it and see what's happening, and really like you were debugging a regular program that you build yourself. Usually it's very hard to do, to debug a code that was compiled just in time, but recent advances in WebAssembly made it possible. And we plan to bring this all the way to our tooling to give you a really smooth, slick experience with tools that you are familiar with. So let's continue this. And we see that we get the response as expected. All right, so this is the first part of kind of developing, building, using the debugger, but none of these things are usable in production. I'll hand it to Edith to talk a little bit about our story and what we're planning to do to enable more production observability and debugging.
Yeah, can you show?
Yeah.
Awesome. So as you've all said, this is very nice. You can build it, right? You can even store it in WebAssembly Hub or in any other repository that you want, registry. You can deploy it, in that case, we just did a very simple deploy for the WASM, and you can debug it. But to be fair, as you said, all of this is very nice, but it's never that simple. This is only on the developer's experience. In one point, you will want to run it in production, and you will never attach a debugger to a production running workload. So the question is, how can we do this? And more than this, our environment usually way more complex than one cluster, one node, one application. It's way, way more complex. And this is an example of what we see in most of the people. You want to go back one second? What we will see in more people, and this is example for 3 clusters, right? With running application that communicate to each other across clusters. You will see here that is as simple as to do a WASM deployment, basically deploy it wherever you want, and you will see the WASM registries automatically is going to take from it. What is important about all of this is that what we see in the market and the customer that we are actually working with right now, I will argue that we probably see between 50 cluster all the way to 100. That's kind of like the average. But we also have even customers that are running 40 data center in production and thousands of clusters. So now the question is, how do you manage that? And of course, debugger is not going to work in that case. So what Yuval is going to show you is about how to do this right now. What is the tooling that we put it for you to do this? And again, everything that he's showing you right now is multi-cluster, which is very important because that's where we're expecting the market to go to. So Yuval, you can show them the next application. And yeah.
Yes. So just for reference, what we're going to see right now, we have 2 clusters. We managed by Glue Mesh, and they have the booking for app deployed. So with that in mind, let's jump into the demo. And let me just clean up. Oh, sorry. Let me make the IDE bigger and start our second demo. Perfect. So let's look at the filter we're going to use. Since we already seen how to build push, we'll skip all that and just go straight into this new filter. It's very similar. It implements the HTTP context like before. We're going to talk about how to do debug logs, how to see access logs, and how to create metrics. And as I'll go to each segment, I'll highlight the relevant part in the filter code that implements that. So the first part, let's just deploy it. And it's very similar to the deploy commands we've seen a minute ago. I'm just telling it to deploy it into the ratings app. All right, so let's talk about debug logging. And debug logging is what you see when you do kubectl logs, right? That's the output of the pod. Now, usually, debug logging is turned off because it's very verbose. Usually, you only log info or warning level. But let's demonstrate if you want to add some debug logging to your filter that you can turn it on when you want to, how we do this. So the Envoy ABI gives us a log function, and you can see right here we use it to just create a log message in a debug mode. Now, what this filter does, I'll tell a little bit about this filter. It accumulates the request body and then parses it as JSON. And once we are done with the stream, once we have received the entire body, we parse the body as JSON, and then we do some processing on it, which I'll cover in a minute. But among other things, we also do some more logging, which you will see happening shortly. So with that, let's continue and make some requests here. So first thing, we'll have to port forward to enable debug logs. So the way to enable debug logging in Envoy, you curl, I'll just show this real quick. You curl the admin endpoint and enable logging. This time we only enable WASM to be debuggable. So moving on. The next step, we need to create a request. So in this case, we curl from the product page pod into the ratings pod, right? We essentially create a request coming from product page to ratings. And you can see everything responds. We even have the header from our previous filter still there. Now, let's look at the debug logs. So remember, we said debug logs are what you see when you do kubectl logs. So let's do kubectl logs. And because debug logs can be verbose, I'm going to grab the string wasm logs that all wasm logs share. And you can see that we saw that call that I was just talking about, the one in the beginning of this function. You see that we are logging the body, and you can see this result of what the filter does. Essentially, what this filter does, it takes all of these reviews and averages them and prints out the average review. Not something you want to do probably in the request path, but this is just for demonstration purposes. All right, so that's debug logs. It's always good to have, you know, just in case things happen, keep them in debug. And then if you don't need them, you don't enable them. Let's talk about access logging. So debug logs you usually only enable when you need them, right? When you're debugging a specific problem in a specific pod, you don't usually globally enable these debug logs or application logs. One thing that you can do on the request path on a larger scale is access logging. Access logging in Envoy is architected to be used on the request path continuously. So let's talk a little bit about how filters interact with access logging. They do not do it directly. It's a bit more subtle. What a filter can do to interact with the Envoy access log is called the set property function, right? And what this does is it sets a property on the request, right? And this is a bit abstract. It's a key and a value. So we say that the property average reviews has this average that we calculated before. It's the same one we printed to the debug log, right? We set it as a property on the request, and on its own, not much will happen with it, right? And let's talk about how we collect these access logs from Envoy all the way to you. So in GlueMesh, we've implemented something called an access log record, which essentially, when created, it configures Envoy to send access logs into GlueMesh. And in this case, you can see that we've asked access logs from both of our clusters. But in order not to be blasted with irrelevant access logs, we only match on a specific path, right? So only requests matching this path will generate an access log. All right, so next step would be to do some port forwards, as always. Get some traffic going. So we port forwarded to two things. One is the product page for the book info. And let me just move my IDE here. And we have the book info right here. The other thing is GlueMesh's networking pod. And that's a pod that the access logs from Envoy will stream into it. And it has an API that can stream them to the terminal. And let me just make this a bit bigger. So now we connect to the enterprise networking pod and we watch for logs. All right, perfect. Nothing's happening because I'm not generating any requests. Let's clear the terminal. And now to generate some requests by vigorously refreshing the browser here. And you can see that it's juggling all the 3 requests from all the clusters. And that is because we have a policy. I'll get to that. Now, let's look at the access log we received. So just to emphasize, this is coming from Envoy in each cluster, sending it to our component in the management cluster. And that component streams that to the terminal using its API. So you can see that we have, what do we have? We have reviews v3 from the remote cluster. We have reviews v2 from the management cluster. We have ratings and reviews v1 from both clusters. So as you can see, all the access logs from all the clusters stream right into the terminal. Now, remember this property. This property in the WASM ABI, it's called a property on the request. Internally in Envoy, it's stored as something called a filter state. So here, if we look for filter state objects, you can see that we have a filter state object, wasm.average reviews, right? So it's essentially this key with wasm.prepended to it. And because the wasm doesn't know what kind of property else it will be stored, it stores it in Envoy as a binary. So this is the binary value that we see, and we can interpret it. You can just echo it and base64 decode it, right? And you can see that it's the exact same average review that we had before. The one last thing I wanted to talk about as far as debugging production is stats or metrics. So let's first see the current situation of our WASM stats. And I'm just grabbing for the stats emitted by this debug filter. And you can see that we have a bunch of OKs and a bunch of errors. Now let's see what happens when I create a request that doesn't have a JSON response, right? I'll just create a bad request, essentially. So I'm going to curl the service, but not in the path it expects, right? I have a 404 not found, not unexpected. And now we can look again at the stats and see that the number of errors was incremented, right? So let's go over the filter code and see exactly what happened. So you can see in the filter, when essentially here is sort of on configuration time, I define these metrics, wasm debug filter OK and wasm debug filter error. And on the request, when it's over and it's time to parse, if parsing was successful, I increment the OK metric. And if it was not successful, I increment the error metric. And that can give you really fine-grained observability. You can use WASM to do more specific observability than what Envoy allows you. In this example, we're creating a matrix based on the body of a response, where usually metrics only give you kind of like the body size. Here you can get really the information that you need based on your specific use case. And with that concludes our demo. And let's go back to the slides and summarize. So what we've seen is debug logs, which are logs that emitted to the pod. You can see them with kubectl logs. Usually you don't enable them in the entire cluster. You only enable them usually to the specific log you need. We talked about access logs and how to get the data from your WASM filter to your terminal. Access logs are something that can be used more broadly, and we showed how GlueMesh makes it easier for you to use access log to debug issues. And we also talked about metrics. And in the demo, I showed I accessed the metrics using the Envoy admin page, and we saw how we can use a WASM filter to create very specific metrics that are business case specific and customized to your need. Edith, anything you would like to add here on debugging in production?
Not too much. Just the only thing that I think that it would be nice if you will show is the UI itself, that they will be able to see the WASM filter there and everything. It's just going to be.
Oh, yes, of course. So let's show you how it looks in the Glue Mesh console. And if we'll go right here, we can see that we have meshes that are...
Make it bigger, no, we can see.
I'll make it bigger?
Yeah. Put it all screen, I think it's fine.
Oh, yeah. One sec. You can see that we have our meshes defined, and you can see our policies that are defined. And one thing to know, the reason we saw all the stars is because we have a policy that essentially routes between all the versions of reviews. And you can see also the WASM filters that are deployed to your cluster. And if we click on one, you can see where it is deployed, right? So if you need to know where is your debug filter currently running, you can see that as well.
Right. And I would just add to it that MeshCTL is basically the command line. Everything that you see here in Glue Mesh is basically a CRD base, right? So this is a very read-only UI, just easier to kind of like wrap around it. But everything can be done by you know, either a CRD or a MeshCTL command line, and that's what you saw most of this demo used.
Yes, and with that, Edith, I'll hand it back to you to wrap this up.
Yeah. Let's move to the next one. Next, no. Yes. So as you say, like, I mean, we talked before that about the experience of it. You know, the idea is that, you know, we need to be able to debug, we need to be able to store and publish, right? We wanted to discover them, we wanted to deploy them on the platform. And what we're adding right now, I think it's all the life cycle of the debugging. How do you actually make sure that what you're running in production is good? And you know, and WASM is there, right? Like, we're running our first customer in production, and this is very, very exciting. So move to the next one, you will. Yeah. So in the nutshell, again, that kind of like to summarize, that's the last slide. What WebAssembly and for filter user experience is extremely important. So first of all, it simplifies the tool, the bootstrap WASM models in Rust, C++, TinyGo, assembly script. We can add more if we need it. It's kind of like a community kind of like request. The second thing is that the infrastructure to build, to push, to share, to deploy, now to debug WASM into SDO service mesh. There is the WASM registry. Again, you can use your own, but this is free, so you can use it. And then the last one is the ability to basically multi-cluster management orchestration of WASM lifecycle, deployment of it on multi-clusters, and then aggregate all the logs and all the metrics to a place that you can easily consume that. So this is in the nutshell the way we see someone using it, and that's how we recommend it to our customer to do, and we wanted to share that with you. And for that, let's move to the last one. So as I said, we are Solo.io. We are hiring.
We're always hiring.
We are always hiring. We are growing dramatically. And there is a lot of resources, a lot of open source projects out there. A lot of people is running it in production. So, you know, just come join us. We are on Slack, so Solo Slack, and we will be right now on the SDO Slack. If you have any questions, please ask.